Okay, let's do another problem like this. Find the area of the region enclosed by two curves. Y sub 1 equals 2 minus x squared, and the other curve, y sub 2, equals x. Okay, there's a problem. This problem's a little more difficult. You know what? They didn't give us any x values for the side boundaries. So we're going to have to just figure out what x should be. Now watch very closely. Here's how you handle a problem where you're given the two curves, asked to find the region in between the curves, but you're not given x boundaries. You step 1, find the points of intersection. The points of intersection for these two curves. Okay, we do that by setting y sub 1 equal to y sub 2 and solving for the x values. Okay, y sub 1, which is the same as 2 minus x squared, is set equal to y sub 2, which is x. Okay, it's a second degree equation. Move everything to one side, the other side 0. Factor the non-zero side or use the quadratic formula. And set each of your factors equal to 0 and solve. You get x sub 1 is equal to negative 2, and another x sub 2 is equal to 1. Okay, so those are going to be our boundaries on the side, negative 2 to 1. Now let's do a sketch to make sure this is physically making sense. Here's our graph, y-axis, x-axis. Let's see, we've got the line y sub 2 equals x, and we've got the inverted parabola y sub 1 equals negative x squared, shifted 2 units up because we added 2. That's an upside down parabola shifted 2 units up. That's graph variations that we learned in previous courses. And then the other graph, let's see, the other graph is y sub 1, that's a diagonal line that passes through 0, and it has the ordered pairs 1, 1, 2, 2, 3, 3, etc. So that's a diagonal line through the point 0, 0. So we've got our two graphs, and we're interested in the region between the two. We found the 2 points of intersection. One of them occurred at x equals negative 2. The other occurred at x equals 1. There they are. Okay, so shade all this region in. That's the area we're going to be searching for. We see the upper graph, y sub 1. We see the lower graph, y sub 2. You might have to graph it to know which one's the upper, which one's the lower. Step 3, integrate to find the area. Okay, we know that the area for these two would be equal to the integral from x equals the leftmost x value, a, to the rightmost, b, of the upper function minus the lower function, dx. So a in this case is equal to x equals the leftmost x value, negative 2 to 1, of the upper function, negative x squared plus 2, minus the lower function, x. So simplify, you get the integral of negative 2 to 1, negative x squared minus x plus 2. Well, that's equal to the antiderivative, negative x cubed over 3 minus the antiderivative x squared over 2 plus the antiderivative 2 times x from x equal negative 2 to x equal 1. The LCD, if I look at this, looks like it's going to be a 6. So I'm going to pull out a 1/6 to the front before I evaluate this because that's my way. And if you don't like it, you don't have to do it. Let's see, I have a big mistake, but I'm going to just scroll down here to where I pick it up. It's equal to 1/6 times, let's see, we have negative 2x cubed. When we pull out the 1/6, negative 2x cubed minus 3x squared when we pull out the 1/6 plus 12x. Evaluated from x equals negative 2 to 1 is 1/6 times the evaluation at the upper limit 1 minus the evaluation at the lower limit 0, which is 1/6 times 27. So the answer is 27/6, which simplifies to 9/2. That's our area between these two curves, 9/2 square units.